Future and promise. A tour of C++, concurrency and utilities. The important point about future and promise is that they enable a transfer of a value between two tasks, without explicit use of a lock. The system implements the transfer efficiently. The basic idea is simple: when a task wants to pass a value to another, it puts the value into a promise. Somehow, the implementation makes that value appear in the corresponding future, from which it can be read, typically by the launcher of the task. We can represent this graphically. Task 1. Get future value. Task 2. Set value, set exception. Promise value. If we have a future x called fx, we can get a value of type x from it. xv equals fx.get, if necessary, wait for the value to get computed. If the value isn't there yet, our thread is blocked until it arrives. If the value couldn't be computed, get might throw an exception from the system or transmitted from the task from which we were trying to get the value. The main purpose of a promise is to provide simple output operations, called set value and set exception, to match futures get. The names of future and a promise are historical, please don't blame me. They are yet another fertile source of puns. If you have a promise and need to send a result of type x to a future, you can do one of two things: pass a value or pass an exception. For example, void f, promise x and px, a task, place the result in px. Try xres. Compute a value for res. px.setValue, res. Catch. Oops, couldn't compute res. Pass the exception to the futures thread. px.setException, current exception. The current exception refers to the caught exception. To deal with an exception transmitted through a future, the caller of get must be prepared to catch it somewhere. For example, void g, future x and fx, a task, get the result from fx. Try xv equals fx.get, if necessary, wait for the value to get computed. Use v. Catch. Oops, someone couldn't compute v. Handle error. Thank you for watching.